So here's the question. It gives us the graph of this function. It's a graph of a polynomial function. And we are asked to determine an equation for this graph. We are asked to write it in factored form and assume that the leading coefficient is 1 or -1. When we write equations for polynomial functions, they will always be in the following form. P of x, or sometimes you may see f of x, k of x, it really doesn't matter. I'm going to use p for polynomial. And then on the right side of the equal sign, it's the leading coefficient times x minus 0 number 1 times x minus 0 number 2 times x minus 0 number 3, etc., depending on how many zeros you have. Well, let's start with the leading coefficient. The problem does tell us that it's either 1 or -1, so we're going to be choosing between those two. And that depends on the end behavior of the function. The function will have a positive leading coefficient if on its ends it behaves like this, so going up and up, or if it goes down on the left but up on the right. So either up and up or down on the left and up on the right. It will have a negative leading coefficient if it goes down on the left and down on the right, or up on left, down on right. So this is positive and this is negative. Well, ours goes down on the left and up on the right. So that's a positive leading coefficient. Since we're selecting between 1 and -1, ours will be positive 1. So I'll write P of x equals 1. The next step is to determine the zeros of our function, because that's what we need for this first factor. We're going to write x minus 0 number 1. 0 number 1 will become a number, and then times x minus the second 0, and so on. Maybe we have the third 0, maybe we don't. We're going to have to see. But zeros of a function are found wherever your function crosses x-axis. Our function crosses or touches x-axis at 2 points. The first one is this -2, and the second one is this +1. And that's it. We don't have any more zeros. So the third one will not be present here. And sometimes you might have more. Sometimes you might have 3 or 4. In that case, you just add this fourth factor, x minus 0 number 4, and so on. So I will write the first factor as x minus -2, because -2 is my first 0, and the second factor as x minus a +1, because +1 is my second 0. Of course, if you have two negatives here in front of the 2, that will turn into a plus. So I'll rewrite this as P of x equals 1 x plus 2 and then x minus 1. Sometimes the factors, and by the factors again I mean this, each set of parentheses, the x plus 1 and x minus 1, x plus 2 and x minus 1, sometimes they will have exponents. So sometimes we'll have to add an exponent here and maybe here. Those exponents are called multiplicities of each 0. So the exponent above x plus 2 will be the multiplicity of the 0, -2, and the exponent of x minus 1 will be the multiplicity of the 0, x equals 1. The multiplicity is determined by how the graph behaves in each 0. There's two options. The graph may be touching the x-axis at the 0, or it may be crossing the x-axis at the 0. Well, it looks like at -2, it touches, and so it touches and then turns away. It doesn't cross it. But at +1, it crosses. if the graph touches, the multiplicity is even. If the graph crosses, the multiplicity is odd. So the smallest possible multiplicity that is even would be 2. The smallest possible number that is even is 2, and the smallest possible odd number here will be 1. So the multiplicity, or the exponent, that I will place in my little red circle for x plus 2, since it touches and it has to be even, the smallest one is 2, will be 2. And then for x minus 1, it crosses there, so I will be putting 1 there. The final thing to check for is what these multiplicities add up to. So the 2 and 1, my little green multiplicities, will add to 3, which means the degree of my polynomial function is 3. So that is my little 2 plus 1 equals 3. Going back to the AND behavior, when I was deciding on the leading coefficient being positive or negative, I said that leading coefficient can be positive in 2 cases. If the AND behavior looks like this, or if the AND behavior looks like this, which is our case. This first AND behavior is with the positive leading coefficient but an even degree. The second AND behavior, which is our case, is the positive leading coefficient but odd degree. And we just checked that the degree of our polynomial is 3, which is odd, so it matches the AND behavior, and that means we're done. The final answer is P of x equals 1, which can be avoided. You don't have to write the 1, and then x plus 2 squared, x minus 1.